Hello guys, welcome once more to PrepClass online physics class. My name is Mr Dami, and in this edition we shall be looking at JAMB Physics 2020 question number 25 to number 13. Now don't forget that if you really enjoyed this video, you should like the video so that you can get more content from us from time to time. As we always say, we have much to show you, there's much to simplify, there's much to explain that will help you in your journey as we go home. Now let's get to check out number 26. Now this one says the refractive index of a liquid is 1.5 if the velocity of the light in vacuum is 3.0 times 10 to the power 8 meters per second. The velocity of light in the liquid is what? Now this question is simply a question on refraction. Do you remember anything on refraction? Refraction. Now you know from refraction we've learned about Snell's rule that says that the sine of the incident angle is over the sine of the refractive angle is Snell's rule, is the refractive index. That's what Snell's rule said, that incident angle and the refractive angle are they are directly proportional, and that was what best the angle the refractive angle. So let's check out the formula to use. Now whenever you have a question on refraction, the formula to use is this. Angle of refraction is the velocity of vacuum over the velocity of liquid. Now this can take different form. You can use sine of incident over sine of refraction, but this question does not have incident and refraction. This question only has velocity or speed. Okay, it has only velocity. So you will not rightly say refractive angle is sine of incident over sine of refraction. That's correct, but that's not the one to use here, because that won't work here because you were not given a sine of incident. So, but you must also know that refractive angle or index is the velocity of the vacuum over the velocity of the liquid. That's the velocity of the incident of the first one over the velocity of the second one. So I said refractive index is the velocity of the first value over the velocity of the second value. So which in this case is the velocity of the vacuum over the velocity of the liquid, right? Okay, good. So let's go on from there. Now we have to find the velocity of the liquid. So making the liquid velocity the subject of formula by cross multiplying, you have velocity of liquid is equal to velocity of vacuum over the refractive index. Okay, is that clear now? Now don't forget that formula. Refractive index is equal to velocity of vacuum over velocity of liquid, or refractive index is the sine of incident over the sine of refraction. If you know that formula, then you've really understood a lot about questions on refraction. Okay, so let's go on from here now. Now velocity of liquid is equal to velocity of vacuum over the refractive index. So the velocity of liquid is the velocity of vacuum is 3 times 10 to the power 8 over the refractive index is 1.5. So give me 3 times 10 to the power 8 over 1.5. So I'll just divide 3.0 over 1.5 and then times 10 to the power 8. That will give me 2 times 10 to the power 8. You know, I always say don't divide or multiply the power of 10. Just divide or multiply the number in the question. And the number that what I just did here is that I said 3.0 divided by 1.5, that gave me 2. I never divided 10 to the power 8. I just put times 10 to the power 8, and that gave me my answer. The velocity of the liquid is 2 times 10 to the power 8 meter per second, and that is the liquid velocity straight up. Now, the most important thing in this question is the formula. If you know the formula, you can blast the question. But if you don't know the formula, then it's like you don't have the key to open the door to solve the question. So formulas are keys. Formulas are keys to solve each question. And if you don't have the key, you don't have the access to that door in that question. Okay, let's check out number 27 now. This is done. So the answer is B, 2.0 times 10 to the power 8. That's very straightforward from the formula. Now number 27 says a ship traveling towards the cliff receives the echo of his whistle after 3.5 seconds. A short while later receives his echo after 2.5 seconds. If the speed of sound in the air under the prevailing condition is 250 meters per second, how much closer is it to the ship? Sorry, is the ship to the cliff. Now, whenever you hear any question on echo, there is one formula to know. Only one formula. If you know that formula, you can solve all questions on echo. And that formula is this. The formula is this. Velocity, echo formula. Speed is equals to frequency times wavelength, or speed is equals to 2 distance over time. If you know this formula, you can solve any question in physics on echo. I'll come again. Velocity or speed is equals to 2 distance over time. We know that before, but that 2 is special. It is equals to, or you can use frequency times wavelength. These are the 2 formulas to use to solve all questions on echo. Now, if you know them, you can use them. But in this case, we're not giving frequency and we're not giving wavelength. So the formula to use is V equals 2D over time. So, but for some questions, you'll be giving frequency and wavelength. Then you use V equals F lambda, which is wavelength. Okay, once you know that formula, then you are good to go. You have the key to all questions on echo. Now let's go on from here now. Now we have to find. We were given that the question says if the speed is this, how much closer? That means what is the distance? So the question wants us to find distance. So cross multiplying, I will get my distance as V times time, okay, over 2. That is the formula to use. When you cross the formula upside down, you will get V is equal to D equals V times T over 2. Now what's my V? My V is 250. That's my velocity. Then my time is from 3.5 to 2.5. Just subtract the time over 2 over 2. So if you saw that, you'll be getting 250 times 1 over 2. So the answer is there for distance is 125 meter, and that is your distance. Remember, it is not difficult. It's just the formula. Once you know the formula for echo, you can solve all questions on echo. Once you know the formula for refractive index, number 26, you can solve any question on refractive index. It's not difficult, it's just a manipulation of formula. Now let's check out number 28, another important one. A ship, so the answer is D here for number 27. Now number 28 says, which of the following statement about the text defect, that should be defect of vision, is correct? Which of the following statement about defect of vision is correct? A, number 1, for a long-sighted person, that should be close object appear blurred. For a short-sighted person, distant object appear blurred. Then 3, short sight is corrected by using a pair of converging lengths. Which one is correct? Now the first one is trying to define long-sightedness. For long-sightedness, what is the meaning of long-sightedness? It's trying to define what is the meaning of long-sightedness. It is the ability to see things that are far, but not being able to see things that are close. So if the object is close, it will not form well. Okay, but if the object is far, it will form well. Okay, it will form on the retina of the eye. Now it is being corrected by a convex lens. So the convex lens makes that which is far to look to come closer, so that it can form on the retina. So that means that the person who has long-sightedness cannot see things that are close, right? So if you are using a convex lens, the person can only see what is far. Okay, it makes the thing that is close to become far. You know, convex lens or converging lens makes things that are close to look far. So the person will be seeing it as far. Okay, so don't forget that long-sightedness is corrected by a converging or a convex lens. So short-sightedness is the ability to see things that are near, but not being able to see things that are far, right? Good. So short-sightedness helps you to see things that are near. Now, it is corrected by a converging, by a diverging or a concave lens. Okay. Now, concave lens make these things that are far to come near. It makes them bigger. Okay, that's what concave lens does. So it makes it be to the eye of the observer who has the problem of myopia, that's short-sightedness. He will be seeing the things that are far, which he can't see, as near. So concave lens makes things that are far to be near or bigger. Okay, it magnifies them. It magnifies them. So that's what concave lens does. So concave lens is a solution to short-sightedness or myopia. Why Convex lens is the solution to long-sightedness or hypermyopia. Okay, so let's take the options now. So the option that says for a long-sighted person, close objects appear blur. That is true. Okay, for a short-sighted person, far things appear blur. That is also true. But the option BM3 says short sight is corrected by a pair of converging lens. Now, is that true? Short sight, converging lens? That is not true. Short sight is solved by a diverging lens or a concave lens, while long-sightedness is solved by a converging lens or a convex lens. So option 3 is not true. But option 1 is true, because the meaning of long-sightedness is that close objects appear blur, because it can only see things that are far. That's why it's called long-sightedness. It can only sight when it is long or far. But if it is close, it will be blur. That's the meaning of long-sightedness. Then short-sightedness means it can only see things that are near. So distant objects are blur. That is also correct, and that's the meaning of short-sightedness. But converging lens for short-sightedness as a solution is wrong, because short sight uses a diverging lens or a what? Or a concave lens. Can you see the picture? Or a concave lens. So that is the solution. That is the answer to number 28. It is 1 and 2. That is correct. So let's check out number 29. Which of the following conditions are necessary and sufficient for total internal reflection to take place at the boundary between the optical media? Okay, for total internal reflection to occur. What do you remember about total internal reflection? Total internal reflection speaks of a kind of reflection. It has element of reflection and refraction, right? Now, like if you are swimming in a swimming pool, you are in the water medium. If you look up, light will flow from your eye to the top of the water, and then it will bounce back. It will reflect the bottom of the water. That means if you are looking up the swimming pool, if you are in the pool and you are looking up, the light from your eye will go to the top of the water, and you'll be able to see. It will reflect the bottom, so you'll be able to see your back. The back, that means the lower part of the water, by looking up, by total internal reflection. Now, the first option, that is a condition that says light is passed from optically denser, that's water, to optically less dense, that is light, and that is air. So if you are in the water, it flows from a denser medium, that's water, to air, that is less dense. So that number 1 is correct. Number 1 is correct because one of the conditions is that it must move from a optically denser medium to an optically less dense medium. So these are all the conditions, from denser to less dense medium. Like in the case of water, you are in a swimming pool, that medium is water and it is denser. To a less dense means air, that means outside the pool. So the first condition is that it must be from denser medium to a less dense medium. Okay. Now the second condition is that there must be reflection and refraction. That's a weaker condition, but it is also part of the condition for total internal reflection to occur. And the third and final condition, which you must take against theory question, is that incident angle must exceed the critical angle. Now, what's the meaning of critical angle? Now, the incident angle is the angle coming from the observer's eyes. Okay, while the angle of the first ray of light. Okay, now in this case now, the ray of light is coming from your eyes, the eye of the person swimming. Okay, so the incident angle is the first angle, while the critical angle is the refracted angle, whose critical angle is 90. Okay, now don't forget the meaning, because I've seen theory questions that were asking for define critical angle. Now, critical angle is a refracted angle, or the refracting angle, whose critical and whose incident angle is 90 degrees. That's the definition of critical angle. Now, the incident angle must exceed the critical angle. That is the last condition for refraction to occur. Don't forget that the incident angle, which is 90 degrees, must exceed the critical angle. Now, let's check out the option. The option 1 says light must be passing from the denser medium to optically less dense, which is correct, like water to air. Then number 2 says light is passing from optically less dense, okay, to denser medium. Number 2 is wrong. It can't go from less dense to denser. It can only go from denser to less dense. Number 3 says angle of incidence is greater. And number 4 says angle of incidence is lesser. In this case, remember I said that the incident angle must be greater. So the option that is correct next is number 3. Angle of incidence is greater. So the correct option is therefore number 1 and number 3. The incident angle must be greater and the light must be moving from a denser medium to a less dense medium. Do you understand? Those are the two conditions, key major conditions, two major conditions for total internal reflection to take place. If you understand that, you understand so much about total internal reflections and their questions in past questions. Okay, let's go to number 30 now. Number 30, the linear expansivity of brass is 2 times 10 to the power -5 degree. That's not supposed to be degree anyway. Now, if the volume of a piece of brass is 10 centimeter cube at 0 degrees Celsius, what is the volume at 100 degrees Celsius? So find the V2. Now, remember, if you are dealing with volume, we have linear expansivity, we have area expansivity, and we have volume expansivity. This is a question on volume expansivity. One of the most important things to remember is that volume expansivity is 3 times linear expansivity. Remember that formula. Volume Y means volume expansivity. The formula for volume expansivity on its own is V2 minus V1 over V1 times temperature 2 minus temperature 1. But it can also have another formula which is 3 times linear expansivity. Now, have you ever thought about it that why are they giving me linear expansivity parameter when they are asking a question on volume expansivity? Look at the question. It says linear expansivity, but the question is not a linear expansivity question. It is a volume expansivity question because they know that you should know that linear expansivity should be multiplied by 3 to give you your volume expansivity. So JAMB know in their mind that if they've given the linear expansivity, they want you to just multiply by 3 to get your volume expansivity. So in their mind, they've already given you the volume expansivity by giving you the linear expansivity. Just multiply by 3. So I began by saying volume expansivity Y is 3 times linear expansivity 2 times 10 to the power -5. Give me my volume expansivity as 6 times 10 to the power -5 per Kelvin. That's the unit of volume expansivity, not degrees Celsius. Per Kelvin. Okay, that's my volume. Now, put it into the formula for volume expansivity naturally. So that will give me Y, that's the volume expansivity, equals V2 minus V1, that's volume 2 minus volume 1, over volume 1 times temperature 2 minus temperature 1. Now we have to find V2, right? So if you cross multiply, your V2 will now become volume expansivity times V1 times theta 2 minus theta 1 plus V1. Okay, so that is my formula for V2 now. Now plug in all the values. My volume expansivity value is 6 times 10 to the power -5 from what I got. Okay, my V1 from the question, my volume 1 is 10 centimeter cube, which is my volume 1, times, okay, times my temperature. My temperature is from 100 degrees Celsius to 0. That's 100 minus 0, right? Then plus my V1, which is 10. So if you solve that, you'll be getting 6,000 times 10 to the power -5. Remember, I said do not multiply 10 raised to the power anything. Just leave it there, but multiply numbers. Okay, so 6 times 10 times 100, that gave me 6,000 times 10 to the power -5 plus 10. That gave me, if I multiply that, that will give me 0.06 plus 10. That will give me, so 10, and that gives me 10.06 centimeter cube as my volume 2, giving me the answer as option A, 10.06 centimeter cube as my answer. No, don't get bad about that. What you just have to know is the formula. Once you know the formula for volume expansivity and for linear expansivity, you are going to get the question right always. It's just to know the formula to use. Okay, now you might want to spend some time with some of these formulas. They are very key, and they are key to unlocking the questions. Okay, so that brings us to the end of this episode. Don't forget to like our videos if you want to get more content from us from time to time. Until we see you next time, guys, take care of yourself. Bye for now.